Yesterday we learned all about matter and how it can be found in three forms on Earth: solid, liquid, and gas. And those forms depend on how the particles of the matter are acting. So we're going to be learning a little bit more about that today. We're going to go more in depth and we're going to take some notes. So you're going to take 3 pages of notes today. So let's get that set up first. Okay, first of all, notebook page 6. You're going to do page 6, 7, and 8 today. Notebook page 6 is your first page. The title of this is Particle Theory of Matter. And we've got 2 main points that I want you to write down right now. First of all, matter is made of particles. And second of all, the movement of particles changes matter from solid to liquid to a gas. And remember, you can pause this video at any time to copy down this note page. After you've done that, we're going to make a chart. We're going to make the same chart for solid, liquid, and gas on the next couple pages. We'll do solid on this page, write solid in the middle, and then I've split the rest of my page into 4 sections. Over here, we are going to draw a model of the particles. Over here, we're going to describe the action of the particles, what they're doing. Down here, we're going to talk about their shape and their volume. And over here, we're going to talk about examples and non-examples. And we're going to be doing the same thing for solids, liquids, and gases. So pause this video, copy down this on page 6 of your notes, and then you can move on to the next page. Okay, page 7 of your notes, you're going to be focusing on a liquid. So again, same things, liquid in the middle, split it into 4 boxes. Here we'll draw a model. Here we'll describe their action. Here we'll describe their shape and their volume. And here we'll describe some examples and non-examples. So that's page 7. And then page 8, same thing, except this time it's a gas, model of particles, particle action, shape, volume, examples, non-examples. Remember, you can pause this video and you can rewind it in order to get those notes set up. Once you're done, press play and we will move on. Okay, so as I mentioned yesterday, all matter on Earth can be found as either a solid, a liquid, or a gas. And the way we move from a solid to a liquid to a gas is by adding heat. Heat just makes those particles move around more, and the more they move, the closer they get to being a gas. If I wanted to go from a gas to a liquid to a solid, I would take away heat, right? I would cool it down. For example, if I had liquid water and I wanted to turn it into solid, I wanted to turn it to ice, I would put it in the freezer, right? I would cool it down and those particles would move around less. All right. So here we go. Let's talk first about a solid. So first of all, what does a solid look like? Here I've got a really cool model. And as you can see here, I have water. Okay, we got H2O, and it's really cold right now. So what is it doing? Well, you think about it. How would you describe its shape? How would you describe what the particles are doing? Okay. So as you saw from the model, the particles are really tightly packed together. Okay, they're tightly packed together, and that's what forms a solid. You can't fit your finger or anything through those particles, which makes it solid. Also, the particles can't move around, but they do vibrate a little bit. As you saw over here, the particles aren't moving around, but they are shaking, they're vibrating. Okay, so that's the particle action. That's what the particles are doing. Make sure you write that in the particle action section after you've drawn yourself a model of what those particles look like. Okay. Your model could be 3D like this, or it could be 2D, right? You can just have one layer to show, basically just show me that the particles are tightly packed together. Okay, now how about shape and volume? Well, the shape of those particles, they have a definite shape. That means that those particles are going to stay in that same shape no matter what container it's in. If I took this brick and I put it in a box, or I put it in a desk, or I put it in a room, or I put it in my shoe, is the shape of the solid going to change? No, that shape's going to stay the same no matter what unless I break it, right? How about the volume, right? Volume, how much space it takes up. Well, it's also got a definite volume, meaning it takes up the same amount of space no matter what container it's in. Again, if I put it in my shoe or I put it in a classroom, is it going to magically fill up the shoe or fill up the classroom? No, it's going to take up the same amount of space no matter what. No matter what container it's in, the shape's going to stay the same and the volume's going to stay the same. Okay, what are some examples of a solid? Well, things like ice or rocks or wood are all solids, right? Their shape does not change if we put it in a container. Their volume does not change. They don't get bigger or smaller if I put it in a container. Can you go ahead and write down 3 more examples? Pause the video and write down 3 more examples of solids. Also, what are some non-examples? What are some examples of things that are not solid? For example, water. Is water a solid? Absolutely not. How about soda or gasoline? Okay, see if you can write down some non-examples of solids and then press play when you're ready to move on. Okay, let's talk about liquids now. So in a liquid, the particle action's a little different, right? In this case, the particles are more loosely packed together and they can move around and slide past each other. You can see in this model here, the particles have a little more space between them, right? Some of them are a little closer, some of them are a little further away, but the main thing is they can slip and slide past each other, which is what makes a liquid a liquid. Let's look at our virtual model over here. So let's change this from a solid to a liquid. Now you can see the particles are moving around much faster and they can kind of slide past each other, all right, which makes a liquid into a liquid. It sloshes around. You also notice it's not filling up the whole container though, right? Gravity is kind of keeping these particles down at the bottom of the container. So particle action, the particles are loosely packed together and they can move around and slide past each other. How about the volume and the shape? Let's just move this out of here. So how about the volume and the shape? Well, in terms of volume, right, it's going to stay the same. Again, it's a definite volume. It's going to take up the same amount of space even when the container changes, right? If I have a gallon of water and I put it in a bathtub, do I still have a gallon of water or did it magically create more water? No, of course. It still has the same volume, right? No matter what, that liquid is going to keep its volume. However, it does change its shape, right? A liquid will take the shape of its container, as you can see in this picture with the 3 different glasses of milk, right? In each one, the liquid has taken on a different shape. Here we've got like, it kind of gets wide down at the bottom. Here's kind of longer and skinny, okay? So the liquid is going to take the shape of its container, and that's because these particles can move around so freely, right? Because they can move around, they kind of slosh in and take the shape of its container. But as you can see, they kind of take up the same amount of space, right? It's not like it's expanding or shrinking. The amount of space stays the same. All right. So make sure you pause that video and write down those notes and draw yourself a diagram as you go. How about some examples of liquids? Well, water, milk, gasoline. Those are some pretty obvious ones. Can you write down 2 more of your own? Pause this video and see if you can come up with 2 more examples of liquids. How about some non-examples of liquids? Right? If a liquid is like water, milk, or gasoline, what's not a liquid? Well, I guess a desk is not a liquid. I'm not a liquid, although I do have liquid flowing through my veins, right? The blood in my veins is liquid. The acid in my stomach is a liquid, but my skin, that's a solid, right? My bones, those are solids. What other non-examples can you think of? See if you can write down another 1 or 2 non-examples. All right, finally, let's move on to gas. So what are the particles doing in a gas? In a gas, they're really loosely packed together and they're flying around all over the place. You can see from this image, the particles are kind of all over the place from the bottom all the way to the top, and there's a lot of space between the particles. Let's go back to our virtual model and let's see. So solid, right? They're pretty much stuck together, not moving around a lot, but they are vibrating. A liquid, they can slosh past each other. And then in a gas, let's see what happens. Oh, wow, in a gas, they're flying all over the place. They're at the bottom, they're at the top, they're on the sides, they're bumping into each other, they're bouncing off the walls, right? So in a gas, those particles are flying all over the place, and there's a lot of space between them. So how about shape and volume? Well, interestingly, a gas is going to take the shape of its container, just like a liquid, right? Just like that milk filled the container, no matter what shape it was. A gas is also going to take the shape of its container. I can put that gas in a triangular container, or a square container, or a round container, okay? And volume also, the volume of a gas, those gas particles will take up the entire container no matter what. Even if you only had one or two gas particles, they're still going to fill up the whole container. So a lot different than a liquid and a solid, right? The solid, um, it's got a definite volume. It's not going to get bigger or smaller no matter, just because you put it in a different container, right? Same with a liquid. Like I said, if you take a gallon of water and put it in a bathtub, it's still a gallon of water. It's not going to fill up the whole bathtub. A gas, on the other hand, right? I might just have a little bit of a gas, but as soon as I blow it into a room or a building, it's going to fill up that entire place, right? So a gas is going to take the shape of its container and fill up that container, as you can see here, right? The gas is pretty much taking the shape of the container and filling up the whole thing. Okay? So before you move on, make sure you've got a model drawn, you've got information about your particle action, and the shape and the volume. Okay, so what are some examples of gases? Well, water vapor is a gas, right? We went from ice to water vapor. Oxygen is a gas. Can you think of another gas or two, another couple examples? Think about what do we when we breathe in oxygen, what do we breathe out? Starts with a C. And what are some non-examples of gases? Well, I guess any liquid or solid would be a non-example, right? Water, ice, those are non-examples of gas. Can you think of another one? Can you write one down?